Hello guys, welcome to our lecture on introduction to queues. Myself Jayaprita and from IT department. I will be explaining you about queues. So let us move into our video. So the table of contents are first we will see what is queue in general, and I will be explaining you with some examples in order to make you better understand. And we will see some characteristics of queue and different types of queues, and what are the basic operations that are implemented on queues, and what are the real time applications of queue. So first we will see what is queue. A queue is also a data structure that is used to store data in a particular order. We would have seen some data structures like arrays, linked list, stack, etc. Right? So, similarly, queue is also going to store the data, and here it works by adding the element from the end and removing the elements from the front. So this is how the queue works, and all the operations are performed in a first in and first out order. That's what we say as FIFO order. This property is exhibited by queue, and queue is also a linear data structure. Like array, stack, and linked list, queue is also a linear data structure. So this is what is queue. Now we will see some example in order to better understand what is queue. So in this example, let us take a ticket counter. Here the persons are entering in a queue in order to get a ticket, and we can see the persons who are entering can enter only at the end of the queue. No entry can happen either in middle or in front. So entry happens only at the end. Likewise, the exit happens only at the first. Here the person who enters a queue first will receive the ticket first and will be leaving the queue first. Likewise, the person who enters at the last will receive the ticket last and will leave the queue after he receives the ticket. So this is how our queue data structure also works. Here the elements are inserted at the end, like how a person is entering at the end. Likewise, the elements are going to enter at the end, and the elements are going to be deleted from the front, like how a person receives a ticket and leaves the ticket counter. This is what real time example that we can say. This will make you better understand what is queue. Now we will see what are some important terms in queue. So here we can see the queue data structure. Here we are giving two terms like rear and front, right? So front is nothing but that is going to be the front of the queue. That is the position of the entry that is ready to be served. That is going to be the first. That is the first element of the queue, and that will be deleted first. And last is going to be the rear of the queue. So that is the last entry of the queue, and it is going to be the recently added one. That is a recently inserted element will be the at the end of the queue. That's what here it is marked as rear. And we will see the NQ and DQ in coming slides. So this is what in general queue will, how the queue will be, queue data structure will be looking. This will be the structure of the queue. So in next slide we will see the characteristics of a queue. So queue can handle multiple data, like we have data like string, float, int, and all, right? So queue can handle multiple data, and it can access both the ends can be accessed from the queue. Here we cannot access any element in the middle, like how we are accessing the elements in middle using index in array, right? In similar way, we cannot access the elements in middle of the queue. So the elements can be accessed only at the end or at the front of the queue. No elements can be accessed in the middle, like how we are accessing in arrays. So this is what is the difference between the queue and arrays. And queues are also fast and flexible. So these are some characteristics. And there are different types of queues that we have. There are 5 types of queue. One is input restricted queue. Here the input can happen only from one side, and the deletion can be done on any of the ends. So the input is restricted and it will happen only from one side. And output restricted queue is nothing but here output will happen on only one side. That is the deletion, and can be done from only one end, and the insertion can be done on both the ends. That's what we say as output restricted queue. And circular queue is nothing but it is like a circular linked list, where the tail of the linked list will be connected to the first, right, that is head, right. In similar way, here the here the last position will be connected back to the first position of the queue. That's what we say as circular queue. And here also the operations will be performed in a FIFO order only. And double-ended queue is nothing but the insertion and deletion can be happen on both the sides, that is front and the rear of the queue. So the insertion and deletion will happen on both sides. And priority queue is nothing but here it is a special queue where the elements are accessed based on the priority assigned to them. So for example, we will be assigning an element first priority, and one element will be given a fifth priority. If second element is given fifth priority and first element is given first priority, means the first priority element will be accessed first. So in this way, there are different types of queues that have different properties. So we will be seeing the implementation of these queues and algorithms of these queues in detail in coming lectures, where I will be showing the detailed structure and some pictorial graphical representation in future lectures for each of these types of queues. So these are some basic operations that are implemented in queue. First is enqueue, is nothing but insertion of an element in a queue is known as enqueue. So basically, as I said, insertion will happen at the end of the queue, and dequeue is nothing but it is a removal of the element from the queue. So basically, it's going to be removed from the front of the queue. And is full is going to check whether the queue is full or not, whether it is completely filled or it has any empty spaces in it. That will be checked by is full. And peak or front, peak is nothing but it is going to retrieve the first element that is available on the queue without deleting that element. So that's what peak or front is going to do. And rear is going to return the last element without removing it. And is null is nothing but it checks whether the queue is empty fully or not. So this is what the 6 basic operations in queue. We will be seeing the algorithm and implementation of these operations in detail in coming lecture. This is just an introduction lecture, so I'm going to just define what all these functions are doing in general. So next is so some of the applications of queue. So queues are actually used in real time applications. For example, let us take our or social medias like WhatsApp, Instagram, or anything. Here, have you ever imagined how these messages are received on receiver end in the same order that we have sent to them? This is basically happening because of queue. Here, queue data structure is used to store the messages in a particular order, and the same order will be received on the receiver's end in the order which we have sent. This is implemented based on the queue only. So uh, it can it is also implemented in printers. We have seen, right, the pages are printed in the same order that we have given. There is no change in order, right? So printers are using queues in order to maintain the pages while printing, and in food order delivery also, queues are used for maintaining the order status, food order status. In computer system, it is used for time sharing applications. In CPU as well as in disk storage also, these queues are implemented. In network, like router, switch and all, will be using queue to deliver the packets in a particular order. And also in mail delivery also, queues are used. So there are different applications where queue is used in real time. So these are some of the examples I have given here. So that's it about this video. In coming lectures we will be seeing about the algorithm and implementation of these queues, and different operations of these queues in detail, and also different types of queues will be seen in detail with an example. And also I will be giving some visual representation and of queues in order to understand it clearly how it works. So that will be shown in coming lecture. So thanks for listening to this lecture.